Well, hello and good evening, everyone. I want to say thank you for joining us for this interesting talk on how to create biodiesel using enzymes. My name is Victor Garlington with 70 cents a gallon. And again, I want to thank you all for taking your precious time to learn a little bit more on how to make this happen. I just want to set some quick ground rules. If you have dogs, kids, or any other noise makers in the background, could you please mute your phones? We will be muting everyone out except for the speakers, but we will take open Q&A questions as well, since this is a conference call. This evening, I'd like to present a pioneer in the industry of biodiesel. He's been in the business, in the biofuels industry for over 30 years. He is a mechanical engineer by trade and makes wonderful equipment. His name is Mr. Ernie DiMartino, and he is a pioneer in enzymatic biodiesel production. Ernie?
Good evening, all. My name is Ernie. Okay, you ready? Okay, good evening. My name is Ernie DiMartino, and I'm the owner of the company called Biodiesel Experts International. We've been producing biodiesel systems now for about 8 years. Initially, we started with the conventional chemical biodiesel systems, but over the last 2 years, we've done extensive work, and we've currently supplied 2 enzymatic systems with 2 more in production and a very large one to be started in Germany within about a month. So, out of all the biodiesel processes I've seen, starting from your chemical processes where you use ultrasonic mixing, cavitation mixing, thin film mixers, through supercriticals, I really enjoy and think that the enzymatic process is the new upcoming process. So with that, if anybody's got any questions, or if Victor, you want to ask questions.
We're going to have Q&A questions after the session. Ernie, let me ask you, you've been in the business for quite a while. What led you down the road to enzymatic production?
Well, in looking at all the different biodiesel processes, there's the traditional chemical process has limitations on the free fatty acid level or the materials you can process. The biggest thing with the enzymatic is that you can process any material from 0 to 100% FFAs, and the process doesn't change. What I mean is that the amount of methanol is always constant. The temperature is 85 degrees and it's always constant.
Well, hold on. You're getting a little ahead there, Ernie. Let's talk about the high free fatty acid material. What do you typically have to do if you're a biofuel producer to bring down that high FFA content in your feedstock?
Okay, generally, if you're going to bring down with a traditional chemical process, you like to be down in the 1-2% FFA range. You can process a little bit higher, but lower is a lot better for reduction of soap manufacturing. Now, there's a few ways to reduce FFAs. One, which is the most common, is acid esterification, where you take a certain amount of methanol and sulfuric acid, you mix it with the oil, it reacts, and it turns the free fatty acids actually into methyl ester. Another way is with solid catalyst. It can be done. I've seen it also done by white film evaporators, where you literally distill out the free fatty acids.
Okay. So, now, when you're doing that, I know with some of our customers that they're dealing with high temperatures, high pressure, not to mention acid, which are typically all things that you don't want to have touch your skin. Can you kind of tell us a little bit on the difference between using acid esterification and maybe a little bit about the enzymatic process now?
Okay, acid esterification is generally done at about 185 degrees Fahrenheit with a reaction time of 1 to 3 hours. With the enzymatic process, there is absolutely no need to do any FFA reduction. I run all different types of materials from 0.5% FFAs up to 80, 90, 95% FFA.
Okay. Now, when you talk about processing different types of material, I mean, are we including tallow in this? Are we waste vegetable oil? Are we doing brown grease? What types of oils have you seen typically through the machine?
In the enzymatic process, we have processed everything from refined oils, just to see how it would work, all the way through used cooking oils, waste vegetable oils, yellow grease, which is another name for waste vegetable oils, brown greases, acid oils, palm fatty acid distillate, animal fats, tallow, chicken. So as long as it's either an oil seed or an animal fat, it can be processed.
Okay, so you're not able to process any types of non-organic material, you're saying, with enzymes?
Right, you can't process, you can't convert a petroleum process using enzymatic.
Okay. I know we get a number of calls about that, people having used motor oil and transmission oil wanting to do something with that. So tell us a little bit more about how these enzymes came to bear in the biofuels industry that we love so much. We're all used to hearing them and seeing them in the wastewater treatment environment and some other environments. How did that happen for biodiesel?
Well, actually, enzymes are in almost every time of walk of life. You have enzymes in your bodies to break down foods and to do different things. And enzymes are used. One of an enzyme that everybody knows about is like OxyClean, soap detergents. And enzymes are used to break down the greases. So what came about a number of years ago was the development of an immobilized lipase or an immobilized enzyme. What I'm talking about is a carrier which has the enzymes impregnated in it. Now, there's two basically enzymes, and that's in the need for taking high free fatty acid materials or the cheaper feedstocks and turning them into biodiesel drove people to invent this type of enzyme to do the process.
Okay. So you're pretty much saying producers, if you are a producer or going to become a producer, I'm not sure of the breadth of experience that we have on the call with us right now, but you're saying they could take a very, very low quality feedstock, maybe even saving their company money, and process this. Will this produce ASTM or EN certified biofuel?
Yes, the enzymatic process will take any of these oils and do a combination of esterification, transesterification. It's only one type of enzyme that you use for the full process. And it brings you to ASTM or EN spec. But you have to remember that depending on what you start with, you may or may not have to use a small post-treatment. For an example, for EN spec, the biggest difference between ASTM and EN spec is ASTM is water by separation and EN is water by what's soluble water. So to make EN spec biodiesel, you need to dehydrate the oil to meet the spec.
Okay.
But I have no problem producing either ASTM or EN spec biodiesel.
Okay. Let's touch base again a little bit about acid esterification when you're trying to bring down the free fatty acids. Typically, I've seen levels as far as methanol usage when you're doing acid esterification as much as 50% to volume. Do you see lower?
No, that's true. Generally speaking, just to give you some numbers, if you're at a 10% FFA level and you're going to do an acid esterification, you're going to use 20 to 22% methanol to drive the process and to convert the free fatty acids to methyl esters or biodiesel. Now, as you go up in free fatty acid level, the amount of methanol starts to jump up drastically. For an example, if you do, like I said, 10% is 22% or 20 to 22% methanol addition. When you get to an FFA level of 40, for every gallon of oil, you're going to use a gallon of methanol. And then when you even get higher, you may have to do it in 2 or 3 steps. So an example, if you had like an 85% free fatty acid level, which is like brown grease or acid oils, you're going to be using approximately 3 to 3.5 times the volume of methanol to oil. So it starts to get economically unfeasible to do it that way.
Okay. So, man, I've read as much as FFA content as far as being used with the enzymatic process. You can process materials up to 100% FFA. Is that true?
Oh, yes. Actually, the enzymatic process loves the higher FFAs.
Can you kind of explain how it works?
Well, basically what the enzymes do is the enzymes are causing the reaction. In other words, in a traditional chemical reaction, you have to add an overabundance of methanol to drive the reaction, which is, I'll get a little technical now, a 6-to-1 molar ratio, where theoretical is 3-to-1. So you have to add the methanol and you have to add caustics, where in the enzymatic process, you add, in a chemical process, you add methanol and caustic to perform the reaction to take the glycerides to turn them into methyl esters. In the enzymatic process, the enzyme is the catalyst. The enzyme is the thing that does the work. So in a theoretical transesterification, it's a 3-to-1 molar ratio. In a chemical reaction, it's a 6-to-1 molar ratio. Using the enzymes, we've discovered that we're about 3.5 moles to 1. In other words, you're close to theoretical. So the enzyme is actually the mechanism or the catalyst that does the work.
Wow, that's amazing. So let's talk about what you actually need. In traditional transesterification, we're talking a sodium methoxide or hydroxide. We're talking methanol, and of course you need oil. What do you need to produce biodiesel using the enzymes besides the enzymes?
Okay, let's start with a chemical reaction. You need to add methanol, a caustic, or some people use sodium methylate, which is the methanol and the caustic all combined. And you, of course, need the glycerides or the oil you're going to convert. Now, in the enzymatic process, and in a traditional process, you need as dry oil as you possibly can have, because moisture in a traditional chemical enzymatic process is like the kiss of death. The higher the moisture content is, it retards the reaction. And you could tolerate a small amount of solids. Now, in the enzymatic process, number one, your oil doesn't have to be dry. It can be up to 5% moisture content, but because the enzymes are in a reactor and they're held, you don't like to fill it up with dirt, so you want to get it as clean as possible. So basically, in a chemical reaction, you need very dry oil, and you have to add methanol and caustic. In an enzymatic reaction, you start out with your feedstock. All you have to do is get it down to 5% moisture content and below, and get the solids out.
Okay, so I guess that's a big difference from what you're seeing traditionally now, because usually you're dewatering, you're trying to filter down to 1 to 5 microns if you can. Do you see the need to do a lot more pre-treatment of oil with the enzymatic process versus the traditional, or is it about the same, a little bit better, a little bit worse?
Okay. Actually, in the traditional process, what you have to do with any conversion of oils to biodiesel, you have to make sure that you get the gross, you have to get the water and the solids out. And this is generally done by centrification, where you use a centrifuge to take out the water and the oil, or the water out of the oil and the solids out of the oil. Now, if your water, or you have an emulsion content that carries the water, then you have to add pre-treating chemicals, and you may have to go to dehydration of the oil prior to processing it. Now, let's step back a second. If you're going to do acid esterification, you must get the oil as physically as dry as possible, because water retards the esterification process. So then you have to dehydrate it. So if your oil coming in is higher than 2 or 3% free fatty acids, or 5% free fatty acids, you not only have to pre-clean it to get out the dirt and the solid matter in the water. To go into acid esterification, the chances are real good you're going to have to dehydrate it also. Now, with the enzymatic process, what we put in front of it, if a guy picks up waste vegetable oil or any kind of grease or animal fat, we usually put a centrifuge in front of it just to get out the gross amount of oil, gross amount of water and the solids. And then we just run it right into the system.
Okay. Now, what's the byproduct? Let's talk about the byproducts of these two different types of transesterification, traditional versus enzymatic. Is it the same? Is it different? And if there are any differences, what are they?
Okay. Basically, in a chemical reaction system, your byproducts are going to be glycerin, you're going to produce soap, and you're going to have an excess of methanol. Now, the excess of methanol you have to get out by one means or another, flash evaporation, you can water wash, you can do it a number of ways. With the, and this is with the chemical reaction. Now, the biggest thing is that your glycerin in a chemical reaction is usually a very dark color, and it's loaded with salts, or I would say caustic salts. And it has a very high level of methanol, because you use so much in the reaction and so much goes with the biodiesel, you have to strip out. An awful lot goes with the methanol. In an enzymatic reaction, number one, because your methanol content is very, very low, and you're not using a caustic, you don't have any salts in your glycerin. Your glycerin is generally, in an enzymatic process, 2 to 3% methanol and 7 to 8% water. And it's, if you have, and everything hinges on your feedstock, but if you have a fairly good, clean feedstock, your glycerin is, like for a crude soybean or something like that, your glycerin is clear. It almost looks, if you didn't know that it had a little bit of methanol and water in it, it looks very close to technical grade glycerin, so you can get a higher value for your glycerin.
Is there a market for that? I mean, what type of market are we talking about for this higher value, clear glycerin, let's say?
There's biodiesel plants now that are making more money on taking waste glycerin from other biodiesel plants, precipitating out the salts, going through flash evaporators and decolorization, and sell it off as technical spec, and they're making more money off of selling the glycerin than they do in the production of their biodiesel.
Wow. That's pretty amazing
Now,
considering
another use for the glycerin, there's lots of uses for the glycerin, but if you can get it to technical grade, just to give you, say, a number, you can get 4 to 5 times more the value for your glycerin if it's closer to technical grade than if it's what I call the glycerin laden with the caustic salts and the high methanol content.
Okay. Now, let's talk about feedstock oils again. We have a number of people with 70 cents a gallon. They actually own their own farms or produce their own feedstock that is virgin oil. And traditionally speaking, when you look at virgin palm oil or any other virgin oil, you have to degum that oil prior to doing your traditional transesterification. Do you have that same requirement with the enzymatic process as well?
No, actually no. In the enzymatic process, the enzymes do its own degumming. There's a big technical explanation in words that are about a foot long that explain what happens, but you don't have to do any degumming. And another phenomena we found in processing corn oils that are loaded with waxes, you don't have to de-wax it either.
Now, is that a tremendous cost savings, I guess, for the producer? I'm not sure what what it costs.
Oh yeah, I mean to degum oil, you have to hydrate the oil, and sometimes you have to use an acid to get out what they call the phospholipids or the gums. That has a cost. De-waxing, it depends on when you want to do it. You could do it at the beginning of the process, or you could do it at the end of the process. What we've also found in the enzymatic process, if you started with a product like corn oil that has waxes in it, once you go through the process where palm oils and greases tend to solidify back up at room temperature, we're seeing that the pour point going through the enzymatic process has been lowered. In other words, it stays fluid. It doesn't solidify up like the original feed material.
Okay. Are you talking more in the lines of cold flow?
Yeah.
Okay. All right. Because
now we can get into that with the enzymatic process. There's no need to get rid of the sterols because we've seen that the numbers are relatively low. It's like 1/3 of the limit using the enzymatic process. So the crystal formation isn't there anymore.
Okay, so you'll pass a cold flow test, no problem.
No problem.
Got it. Now, let's talk about the actual introduction of the enzymatic process into a system. Now, can we just buy enzymes and put it into our traditional, reactor, and will it do the job in that scenario, or is there some special handling we need to be aware of for handling these enzymes and producing biodiesel oil?
Well, basically, the enzymes come as a immobilized lipase. They're on a carrier. They're very seldom, if people know, in the traditional biodiesel manufacturing where you use ion resins to clean the biodiesel at the end. They're very familiar. They look the same. They don't act the same, but they look the same. So basically, the enzymes come to you packaged, and they have a shelf life of a year in a dry state. And you have to keep them, out of high humidity, and you want to keep it in an ambient temperature. You don't want to store it where it's going to be 120 degrees. So basically, the enzyme are a very stable type of material that you don't have to take a lot of care of.
Okay. So you're saying if I have a processor right now that I'm using a traditional way, you said I can just get rid of my caustic and go get some enzymes?
No. Basically, the systems, the enzymatic process cannot be used, the immobilized enzymes cannot be used in a traditional batch type operation. It has to be a continuous. Your reactors have to be kind of specially designed so that they hold the enzyme in the reactor, and the reactor needs to be jacketed because you want to keep the enzymes, the optimum temperature is 85 degrees Fahrenheit. So you can take a conventional system and modify it to use the enzyme, but you just can't take a vessel and throw the enzymes in and expect it to work. So you have to have a special system.
Gotcha. So you're saying this goes from a batch to a continuous operation when you're talking enzymatic processing?
Yeah, with the immobilized enzymes, it's always a continuous process. What goes in one end comes out the other end.
Okay. So what if I go on vacation for a week? I mean, what happens if my people or plants shut down? Can you just stop production, or does it kill them, or what happens to the enzymes then?
As long as the enzymes, once you wet the enzymes, you have to keep them wet. So basically, as long as they stay in the reactor and the reactor is full of liquid, you're fine. We have had where we've shut down processing for 2-3 weeks. Basically, with the enzymatic process, if you had to go home on a Friday and come back on a Monday, you just shut the whole system down. You make sure that the jacket temperature of the enzyme stays at its 85 degrees, the reactor stays at the 85 degrees. You come back in Monday morning and you start up the system and you start processing again. The other thing of it is, because the amount of methanol and a little bit of buffer, which is like a water mixture, that's add never changes. So you can go from corn oil to waste vegetable oil to brown grease to like crude soybean or palm. You can switch from one to the other, but you can start and stop the system as much as you want. And like I said, you can leave it idle for 2-3 weeks. It doesn't hurt anything.
Okay. Now, you mentioned that you could stop at any time. Is there an extended startup time to get things rolling again once you stop it?
No. Basically what you do, let me explain the process a little bit. You take your vegetable oil and you put it in a tank. To that, you add a certain amount of methanol, which is so close to, if you had an FFA, as 1 or less. So you add a certain amount of methanol and you add a certain amount of what we call a buffer solution. It's sodium bicarbonate and water. I call it like an Alka-Seltzer. And you put a very little amount of this because actually the enzymatic process requires water to work. So you make this premix, you feed it into the first stirred reactor. It goes through the first stirred reactor, it settles out so you can drop the glycerin. You do another little polished second stage reaction, and basically you end up with your biodiesel. Now, you'll have to do a small post-treatment to get the ASTM or EN. But it doesn't make any difference. You can shut it off. You can turn it on. The shutdown time is you go up, you hit a button and stop the flows going into the system. And to start it up, you hit a button and you start the flows back up into the system.
Well, so this really sounds like a great new alternative, Ernie. I mean, can you tell us a little bit about cost? I mean, what is the cost, traditional versus the enzymatic process? What are the cost differences that we can look at?
Okay. To make this real simple, number one, irregardless of the level of free fatty acids, the amount of methanol you use, which by volume is a maximum of 25%. Actually, we're finding out 20% works fine. But when you get to the cost, you have no caustics. You have a reduction in methanol because you don't have any FFA problems, or you don't have any esterification you have to do. And everything operates at 85 degrees. So when you build the system, Everything operates under like 1 bar or 14 psi, so you don't need any special code tanks. So the thing of it is, when you talk about the cost, the actual processing cost per gallon, and I'm going to give you generic or a little bit high price. An example of, if you had a waste cooking oil that had 10% free fatty acid, you had to do esterification, you could figure that your cost of production with the cost of the methanol, the electricity, the manpower, overhead, is about $1.50 a produced gallon. With the enzymatic process, you're down to about $1 a produced gallon.
$1.
And that's for any type of oils, whether it be yellow grease, brown grease, palm oils, acid oils. It all comes out the same.
Wow, that's pretty good. That's pretty good. So what's your conversion rate of the material once you have it done then? Is there any leftover? Or?
On all the material that we've done, now let's talk about conversion of material. You got to understand that in your feedstock, you may have materials that aren't convertible, okay? But of the glycerides, our conversion rate has been, I'll say better than 99%. We actually are seeing 99.5% conversion on all the convertible glycerides in the oil.
Okay. So let's talk about, it's 85 degrees and you get a pure glycerin, I guess. What's the purity of this glycerin that you're talking about?
Well, to be perfectly honest, the purity of the glycerin depends on what the feedstock is. If you have, let's say, a 10% free fatty acid, waste vegetable oil, used cooking oil, the glycerin generally is close to clear. It's like a light yellow color, and it has 2 to 3% methanol and 7 to 8% water in it. Now, I've seen it with palm oils that had no pre-cleaning at all. Well, what happens is some of the suspended solids will drop out into the glycerin. And it's a funny thing because you'll see 2 layers of glycerin. You'll see a clear layer of glycerin, and you'll see a clouded or a darker color glycerin because it has suspended solids in it.
Okay. Well, let's talk about this. It sounds very technical. I mean, what type of training does one need to run a unit like this or a machine that uses an enzymatic process?
I would basically say a high school education would be just fine. The enzymatic process is generally pretty simple, and the process is continuous and it's all automated. So actually, the operator, all he has to do is make sure he has supplies of material to feed into the system and do visual and very menial or very simple tests to prove that it's ASTM or EN-spec fuel.
Okay. So how many people...
In other words, you don't have to be a rocket scientist to run it or a PhD chemist, okay?
Okay. You talk about enzymes, a lot of people probably are like, whoa. Well, what sort of crew or staffing do you need to run an enzymatic unit like this? And is this an automated unit? Do you just push a button and walk away? I mean, how do you have your unit set up?
Okay. They are automated systems that connect to, through an Ethernet connection, they connect to the internet so you can monitor and watch the system any place you are in the world. If you get an alarm, there's protocols and things that will tell you if you have an alarm. The actual manpower to actually run the enzymatic system, I would say one person, but you can never have a plant with only one person in it. So you'd have to have 2 people per shift. But their actual involvement in the enzymatic process is very little.
So you said something pretty intriguing there. You're saying that this whole process can be observed and monitored via the internet
Right,
with your unit?
right. Actually,
Huh.
inside the control panel, we put a PC that downloads all the information. In other words, flow rates, the addition of the methanol or buffer solution, the temperatures of the reactors, all the valves. All this data gets downloaded into a PC that's in the system, in the control panel, and from there it's connected to the internet, and anybody that has the code to get into, sign into it, can visually see what's going on.
Well, you mentioned that this whole solution or these enzymes need to stay at an 85 degree Fahrenheit operating temperature. How do you ensure that happens with this type of production?
Well, because they're jacketed reactors, we supply a system that is like a combination chiller heater, and it depends on the location where you are. If you're up in Canada where it never gets over 85, 90 degrees, you don't need a heating system to maintain the reactor temperatures. The enzymes like 85 degrees. If it's colder, you'll never hurt the enzyme. In other words, if it drops down to 70 degrees or 50 degrees, the only thing you might do is lose production because they're not as lively, they slow down. And there's a high limit. You don't want to go over, say, like 100, 110 degrees because you get to the point where you're going to damage the enzyme. So the systems come with the jacket cooling or heating system, and in some applications, like in the Caribbean where electricity is sporadic, we even supply backup generators so that if you lose electric power, it'll go in a standby mode and the system will stop processing, but the reactors are kept at the temperature at that 85 degrees Fahrenheit.
Okay. Well, let's talk about these enzymes for a second here, Ernie. I mean, when you think about an enzyme, I know different people probably have different thoughts depending on their exposure to them. Are we talking one enzyme, two enzymes? Do I have a cycle of enzymes to do this?
No, basically a full-blown, in other words, if you start from used cooking oil to ASTM spec, you use one. We call it Biocatalyst A. And that Biocatalyst A is a proprietary formula of one or two enzymes or three enzymes that are attached to a carrier. So that
Okay.
the enzymes are just a proprietary combination that's attached to the carrier that does the work.
Well, if you get on Google right now, you see some different providers out there claiming that they have enzyme production as well. And, I saw some information on liquid versus a mobilized enzyme. What's the difference there?
Okay. There's basically two enzymes that are being used today in the production of biodiesel. One is, which the one I like better, is the immobilized lipase, and that's held in a reactor and it's continuous flow. The other enzyme is a liquid enzyme, and there's many, many people that manufacture liquid enzymes for all different things. But for biodiesel production, the liquid enzymes are used in a batch type application. And the enzymes go out with the glycerin, then you have to separate them from the glycerin. So it gets a lot more, what I would say, labor intensive and a lot more critical. So there's two types of enzymes. There's a liquid and then there's an immobilized.
Okay.
The liquid one is generally, the liquid one is a batch application, and the immobilized one is continuous.
All right. So when you talk about an enzyme, we're definitely talking about something that is alive, an organism. What is the reactable life of that organ? I mean, how long do they last?
Well, the enzyme starts from 100%, let's say, activity, and as you use it, it decreases over time. Now, we guarantee the activity level of the immobilized lipase for 6 months. But in actuality, in very high, because something has to give, in very high FFAs, like 80, 90% FFAs, we're seeing a life of 8 to 9 months. And it's not that the enzyme dies off completely. Once you get below like 70% activity level, you start losing production. So it becomes economical. It becomes an economics thing. But the enzyme that is guaranteed for 6 months with very high FFAs, we've seen 8 to 9 months life. On relatively low FFAs, like 20% or less or 30% or less, we're seeing as much as a year.
Okay. Now, is this something you would say like a Pure Light, when you're dry washing, you have to remove all of that material and start fresh with new material, or can you top off the enzyme to increase the productivity again? What's your recommendation for that?
Well, you can. Let's say you're running the enzyme and you're starting to see productivity drop. You can drain 50% of it out and add 50% new. But you're still going to have 50% that is starting to get below the limits you want. The best thing and what we recommend is that once you get below a certain activity level, which we send you a test procedure to monitor the activity level of the enzyme, and we also do it, but we recommend that when it gets to a point where the enzyme isn't working as well as it did before, then we say drain the whole thing and replace all the enzymes. And what you have to remember is that the enzyme is a production cost. It's not a capital cost. So the cost of the enzyme goes into that price that we spoke about before of how much it costs to produce 1 gallon of biodiesel.
Well, let's talk about that production versus capital cost compared to traditional, biodiesel production. What type of cost per gallon are we seeing with the use of the enzymes?
We're seeing any place between, the range is generally as low as about 70 cents per produced gallon to, in some cases, it goes up to...
Hey, I like that name.
70 cents a gallon, right? And it depends on labor and where you are and cost of methanol, but it can go, upwards of $1.10, $1.20 tops.
Now, what is the determiner? Is that the type of feedstock you have, or is it dirty feedstock versus clean feedstock? What determines that price difference there?
No, the price difference is determined by more your cost of utilities, your cost of methanol, and your overhead cost.
Okay.
The cost of the enzyme always remains the same.
Well, Ernie, we really do appreciate you giving us this very good information about enzymatic production. I'm sure a lot of us are really appreciative. So everyone, what we're going to do now is we're going to unmute your lines. If you have a lot of background noise, please be mindful of the others here on the call. We're going to open it up to your questions. Since this is a conference call, we'll just take one question at a time, and we have about 15 minutes left on the call, so we can get through to everyone. It appears that we have about 15 people on the call right now. So what I'm going to do is go ahead and unmute everybody, and we can go ahead and, if you have a question about production, or if you have a question specifically for Ernie, please go ahead and ask right now.
What does a unit cost to build?
The unit depends. It depends on how much production you wanna do. Okay, and the size of the system is determined by the production level you want. We're currently producing systems, and the way we size them is from 50 liters per hour, which is about 13 gallons an hour, and I'm currently working on a project for 5,000 liters an hour in Germany. Now, just to give you a range, you have to understand that the hardware, the system, the automated system, if you were going to build a conventional chemical process that was continuous, if you could say you can make it continuous, the cost of the system for a chemical process versus an enzymatic process is almost the same for the equipment. Now, to answer your question, because I know you want to answer, we're looking at about, for a small system to do 750,000 gallons a year, and this includes the cost of the enzyme. And please remember that the cost of the enzyme is an operating cost. It generally runs that the enzyme cost and the system costs are almost equal. So for a very small system, you're talking maybe about $150,000. And they go up from there.
And $150,000 would make how much per year?
About 750,000 gallons.
So you said about 250,000 gallons?
No, 750,000 gallons.
Oh, 750,000 gallons. Okay. All right. Great. A great question. Was that Eli? Great question. Great question. So what other questions do we have out there? What about you, Gordon? Do you have any questions, sir?
Continuous feed, you say you can start it and stop it, and the process is just in limbo. And your generator will just keep it at that temperature. Why doesn't the generator also power the whole system?
You can. Actually, the amount of power you need to run the system is just pumps in some stirrers, depending on the size of the system. You can size the generator so that if you lose power, you can keep going with the production. But generally, we size the generator so that if you lose power, rather than having a monster generator, if you lose power, it just maintains the cooling system on the unit.
Okay. Gordon, did that answer your question, sir?
Yes, sir.
Okay, great, great. How about you, Elena? Do you have any questions? You've been pretty quiet tonight. No. All right. And we have Abdul. Abdul, do you have any questions, sir? All right. Well, we have Mr. Griffith.
Can you hear me?
Yes, we can.
Yeah, what I want to know is, he mentioned that to use that type of enzyme that you need to have a special type of reactor for it. So if I wasn't using that enzyme, will I have to retrofit my reactor to use that enzyme? And if I do, what are the procedures, the cost and all of that stuff to do that?
Well, basically the cost of retrofitting. Let me explain the difference. In a chemical reaction, you have a tank, and let's say you have a mixer in it that stirs it round and round, okay? And by one means or another, you're going to have to heat it up to about 140 degrees to get a good reaction. It could be either a jacketed tank. It could be with, some people stick electric heaters right in the tank, which I don't like. Or you can use any kind of other heat source to get the material up to temperature. If you were to take that vessel, right, because you have an immobilized lipase or immobilized enzyme, you have to put, number one, you have to put some kind of screen in the bottom so the enzyme stays in the reactor.
Right.
So you have to cut the bottom off and equip a screen. Now, you have to have a special design mixing blade that gives you rotational mixing and not stirring from top to bottom. So basically you come in with your pre-mixed material, you go into the stirred reactor that has a screen to hold the enzymes in it, and then the liquid comes out continuously, and then you go to a simple settling tower or acetylene tank to separate the biodiesel and glycerin.
Okay.
Okay.
It depends on what you got, what you start with.
Right. It just seemed like you could just go inside, do some inside tank work to put the screen on it, and change the mixer.
Right.
Okay.
So basically what you can do is if you've got an existing mixer coming down from the top, we have to modify the blade design. And on the tank, you have to equip a screen. Now, the other thing of it is if your tank is not, if you're in a hot climate and you don't have a jacketed tank or coils around the tank to keep it at 85 degrees, you're going to have to do that.
Mm-hmm.
Okay.
Okay.
Well, Mr. Fontaine, did you get your question answered there, sir?
Yes, it's answered.
Okay, great, great.
I have
You're
one
welcome.
other question.
Go right ahead.
Is there any difference in the permit process from chemical versus? No.
I'm sorry, Gordon, you were breaking up. Can you pose that question one more time, please?
Sure. I was asking, is there a permit to install one of these plants? Is there a significant difference in going through the permitting process?
There's absolutely no difference. Actually, a chemical plant, because of the volumes of methanol you're using, is more of a pain to get the permits for than the enzymatic plant.
Okay. All right. We have Elena as well. Elena, did you have any questions? I thought you had tried to speak up one. Okay.
Good.
Well, is there anyone on the call that would actually like to visit the plant and see a machine?
Sure.
Let me just throw something in here. Okay. Currently, there are no production enzymatic plants in operation in the United States. We have them in Israel. We have them in Japan. We have them. There's one in the Netherlands. So there's plants around the world. As of the end of this month, we'll be delivering and starting up a system for the city of Dallas for their school bus system. And that's a 300-liter an hour system. So by the middle or end of November or after Thanksgiving, we will have an actual operating plant here in the United States people can visit to see.
Well, that's pretty exciting.
And shortly after that, there'll be another one up in Maine, but that'll be after the first.
I want to put one in Detroit.
We can put them any place, you know. I've actually enzymatic systems that I have produced. There's one in Hong Kong that's waiting for startup. There was one that was just shipped and delivered to Italy. There's another one that's being built for Montenegro, which is another European country. We're building the one which will be finished very soon for the city of Dallas school system. There's another one for a fuel distributor up in Maine. And I also have people in Georgia. I've got people I talk to all over the United States, and everybody's waiting, and I'll be honest with you, everybody's waiting for the Dallas unit to be up and running so they don't have to travel overseas to see this work.
Well, that's great news, Ernie, for everybody. So what we'll do is, for everyone on the call that's registered, we have your email if you registered. Of course, you registered to get on the call. So we'll go ahead and send you that contact information. If you have further questions, make sure you send them to me, Victor at 70 cents a gallon or info at 70 cents a gallon. But everyone that registered will get a thank you for joining us, and we'll have more information on how you can access or gain access to the plant and also to Mr. DiMartino. Well, with that, I want to thank everyone and be respectful of your time and say thank you so much for joining us. And I'll end the call at this time. Let's give Ernie a round warm of applause. Thank you, Ernie.
Thanks, Ernie.
Thanks all of you for putting up with this hour listening to me explain this. So we look forward to hearing from you, and if you have any questions, do not hesitate. Thank you.
All right, everyone. Have a great evening. Thanks again.
Thank you.
Bye-bye.
Great call.